Hello scholars, welcome. Mr. Hinkle here, and we are continuing our discussion of plate tectonics. And in this lecture, I want to make it more complicated in order to make it more easy to understand. What? Okay, we're talking about Earth's physical layers. Now, the objective of this lecture is to define the physical layers of Earth looking at the lithosphere and the asthenosphere. So let's take a step back. Earth has a layered structure, and if you've seen my lecture on Earth's internal structure by chemical composition, we know that Earth is composed of the crust, the mantle, and the core. Crust, mantle, core. These are by chemical composition, and they vary by their density. The core is iron and nickel, the mantle is the rock type peridotite, and the crust is made of superficial rocks, basalt and granite with variations on those. It's much more complex, but for simplicity, right, this is where we are. There are also physical layers that go through the crust into the very upper part of the mantle. And they don't exactly correspond with the chemical layers, but they are important because they exhibit different qualities, and it's the framework for understanding how plate tectonics works. So before we get hung up there, I just want to say, plate tectonics is the theory that the surface of Earth is covered by large, rigid bodies of rock, and they move across, they being tectonic plates, move across Earth's surface relative to one another, and where they meet at tectonic boundaries, they have specific interactions responsible for earthquakes and volcanoes, ocean building, mountain building, landform creation. So geology views the Earth system processes through the lens of plate tectonics. Well, that's pretty simplified, right? Large bodies of rocks travel across the surface of the Earth. How do they do that? Well, the lithosphere travels along top of the asthenosphere. The lithosphere is the uppermost layer of the Earth. So let's do this. I'm going to build this piece by piece for you. And the first thing I want to build on here is continental crust and oceanic crust. Sticking to this one because we are going to bring it in. So continental crust is less dense, thicker, and older than oceanic crust. Relative to, yeah, I said that. Oceanic crust is thinner, younger, and more dense. Oceanic crust we can even bring this in to a bit of a subduction zone. Oceanic crust will subduct underneath continental crust. That means that, let's say here, the green line is the moho. The crust mantle boundary. So here we've got crust, and below the crust is the mantle. Awesome. Okay. Crust, mantle, core, simple. Chemical layers, chemical layers. But we want to bring in physical layers because the uppermost part of the mantle is rigid too. And that part is called the lithosphere. So I'm going to say, let's put this here. Fallen pens. Here is the moho. And the uppermost part of the lithosphere is going to extend from the crust to just below the moho. And we call this the lithosphere. So D, D, D. This is going to be the lithosphere. The lithosphere is Greek for stone. It's discontinuous and broken into segments. These are tectonic plates. Tectonic plates are lithosphere because they are the solid bodies of rock. Sometimes we use it interchangeably with crust because the crust is also solid rock, but the lithosphere is really what we're thinking about when we're talking about the physical characteristics. Solid bodies of rock are the lithosphere. Underneath the lithosphere, we have the asthenosphere. And the asthenosphere is part of the upper mantle. Asthenosphere. Okay, getting that quad work out here. Let's go. The asthenosphere. The asthenosphere has a different physical quality to it. The asthenosphere has the ability to flow. And the words we use here are ductile or plastic. Plastic can flow, plastic can bend without breaking. The lithosphere is rocky, it breaks. And so I think of this like a big tub of honey, and I wish I had one. I might scoop some honey out because it sounds delicious. A big tub of honey, and you take peanut brittle and you break the peanut brittle into big chunks and you set the peanut brittle on top of the honey. The peanut brittle is the lithosphere, the upper layer that breaks. The honey is the asthenosphere, the lower layer on which the upper layer sits on top of. So these are the physical characteristics. Earth's internal structure by chemical characteristics, crust, mantle, core. By physical characteristics, lithosphere and asthenosphere. So the crust is the thin layer of distinctive chemical composition overlying the mantle. Little textbook definition. The lithosphere is the rigid outer layer, which includes the crust and the upper solid mantle. The asthenosphere underlies the lithosphere, and it flows. It's part of the ductile mantle that flows over geologic time. And it is this model that says large rigid bodies of rock, tectonic plates, can move over the surface of Earth. They're moving, that is actually saying lithosphere travels over asthenosphere because the asthenosphere has the ability to flow. This is important because this really ties in our model for plate tectonics. Not only do we understand the chemical composition of Earth's layer structure, but now we have a physical representation that allows our model for the movement of large rigid bodies, i.e. tectonic plates, to occur, whereby the crust and the uppermost mantle that are all rigid, the lithosphere, move over the ductile part of the upper mantle, the asthenosphere. And with this, plate tectonic works. We have a mechanism. We have internal layers by chemistry. We have physical layers that allow us to really understand the processes that create mountains, that open oceans, that are linked to volcanoes. Pretty much every landform on Earth we can understand through the lens of plate tectonics. And plate tectonics necessitates both a chemical composition viewpoint and a physical characteristics viewpoint. So this is the physical layers of the Earth. It's the very surface of the Earth, and it helps us to put tectonics into a framework of understanding so that we can dive deeper into more complex processes. Thank you so much, and I'll see you again.